Bismillahirrahmanirrahim. In today's lecture, we will discuss about the ionized and unionized ratio of weak acid and weak basic drugs uh, using the Henderson-Hasselbalch equation. As we already know that this Henderson-Hasselbalch equation, it is very helpful to calculate the ionized and the unionized form of any acidic or any basic drug, because most of our drugs they are either acidic or they are weak basic drugs. तो ज़्यादातर हमारी जो ड्रग्स हैं either they are weak acid और the weak basic drugs जो हैं. सो द एंडरसन हेसलबॉश इक्वेशन जो हमने लास्ट टाइम डिराइव किया है कि हाउ टू डिराइव द इक्वेशन फॉर वीक एसिड एंड वीक बेसिक ड्रग, उसी इक्वेशन को यूज़ करते हुए टुडे वी विल कैलकुलेट what is the ratio of the ionized and unionized form of drug at any specific pH. क्योंकि हमारी बॉडी के अंदर जो डिफरेंट फ्लूइड्स हैं, डिफरेंट पार्टीशंस हैं, देयर इज़ डिफरेंट बिटवीन द pH एट different body organs. pH is different in case of stomach, intestine, then going to the brain, and in the blood, and in the urine that pH is different. So that's why the ratio between the ionized and the unionized form of drug it vary depend करता है, because the pKa value of any drug it is fixed. हमारी pKa value जो है ये हमारे हम mostly fix होती है, and pKa value is always for the drug. जो pKa value है it is always for the drug and pH is always for the fluid. pH किसी ड्रग की नहीं होती, it is always for the fluid या solution की pH होती है. So the pKa is fixed and we can determine कि if the pKa is low कि ड्रग किस तरह की है, acidic है, basic है, and then the structure of the drug helps to look into कि ये ड्रग acidic है या basic है. So using the knowledge of this pKa we and the structure of that drug, we can use appropriate equation to calculate the ionized and unionized form of drug at any specific pH. So let's move to the first slide. As already I have mentioned कि जो Henderson Hasselbalch equation है for weak acid और weak basic drugs के लिए, it is derived in our previous lectures. और इसके लिए जो इक्वेशन वो हमने डिराइव की थी that was the pH of the fluid is equal to pKa value of the drug plus log of ionized and unionized form of drug. और जो बेसिक ड्रग के लिए हेंडरसन हेसलबॉश इक्वेशन है that is pH is equal to pKa plus log of non-ionized divided by ionized form of drug. तो दोनों इक्वेशंस में at pH level they are same, at pKa value they are same, and the only difference is between the ionized and non-ionized ratio or the non-ionized over ionized ratio. ये वाला इनका डिफरेंस है, otherwise the equations they are mostly the same. तो इक्वेशन इनकी सेम है. This is the difference के जो एग्जिस्ट करता है pH pKa वैल्यू का. Okay, so moving to the next slide, because if the drug is acidic in nature तो हम I mean के फर्स्ट इक्वेशन अप्लाई करेंगे, और अगर ड्रग इज़ बेसिक इन नेचर तो रेशो कैलकुलेट करने के लिए हम सेकंड इक्वेशन को यूज़ करेंगे. सो फर्स्ट मूविंग टू द एग्जांपल्स ऑफ द acidic drug, very well known drug that is called as the aspirin. Chemical name is acetyl salicylic acid, and its ionized and unionized ratio in the pH of 5.5. अगर pH किसी fluid की 5.5 है, suppose the pH of the intestine if it is 5.5 and the pKa value of the aspirin that is fixed, it is 3.5. So if the pKa value is 3.5, pH is 5.5, what will be the ratio of ionized and unionized species at that 5.5 pH? So the formula is pH is equal to pKa plus log of ionized over unionized form. ये इसका simple formula है, and we know that the pH is equal to 5.5 pKa A is equal to 3.5 and then log of ionized over unionized species. और यहाँ पे it is going to be added, तो on other side ये दूसरी साइड पे जाके माइनस हो जाएगा and the answer will be you can say कि will be equal to 2 आंसर होगा क्योंकि it will be in minus form. बट ये है कि अदर साइड के ऊपर हमारा log है, so ये जो log है it will be again shifted to other side as anti log. तो हम इसको जब इसका एंटी log निकालते हैं the answer will be equal to 10 raised to power 2 and 10 raised to power 2 is equal to 100 and 100 it means the ratio between the ionized and the unionized form of drug is 100 divided by 1 which speaks that के नोमिनेटर के लिए नोमिनेटर है और डिनोमिनेटर के लिए डिनोमिनेटर है. So this is the nominator. I mean the ionized form is 100 molecules. If they are there, only single molecule will be of the unionized form of that drug. So the aspirin at pH of 5.5, it will be because the pKa value is 3.5 at pH 5.5, it's 100 molecule. If there are 100 and one molecules, the 100 molecule will be ionized and only one molecule will be in unionized form. So basically what does it means? It means that if we increase the pH, the ionized form of aspirin will be increased. तो इसकी ionized form जो है ड्रग की increase होती है. So this is the basic equation. और इसकी जो दूसरी equation है that is the weak acidic drug in the stomach के अंदर अगर हम इसको देखें where the pH is 2, तो वहाँ पे हमें क्लियर हो जाएगा कि ionized और unionized की रेशो क्या है. So again the equation will be the same, pH is equal to pKa log of ionized and unionized and this is 2 and other side it will be -2, तो ये -2 हो जाएगा और ये log है एंटी log होगा. So 10 raised to power -2 and 10 raised to power -2 is equal to 0.01. 0.01 is equal to 1 by 100. So this speaks that nominator is ionized is for the nominator and for denominator is there. So only single molecule will be ionized if the pH is equal to 2 and the drug has got pKa value of 4. कोई भी drug है आपकी उसकी pKa value 4 है and it is acidic in nature और pH 2 के ऊपर the drug will be you can say mostly in unionized form. So as we increase the pH, ionization increases. As we decrease the pH, the degree of unionized form of that drug that increases for the acidic drugs. तो ये रूल हमारा अब कांस्टेंट है कि जो ही हम pH को डिक्रीज करते हैं unionized form of drug that decreases. If we increase the pH, the ionized form of that drug it increases. तो ये इसका basic difference है. Now moving to the next slide. If you see the next slide, that is about the weak acid drug with pH is equal to pK or pK is equal to pH. एक generalized formula है when the pH is equal to pK, whether the drug is acidic or the drug is basic in nature, the ratio of ionized and the unionized form will be equal to 1 by 1. This is the general formula और it should be very clear कि जब पी के पी एच की इक्वल होगी ड्रग बेसिक है एसिडिक है द रेशियो विल बी इक्वल टू 1 एंड यू कैन से कि आयोनाइज्ड और अनआयोनाइज्ड फॉर्म 50-50% होगी. So this is the equation pH is equal to pKa plus log of ionized over unionized. pH is equal to 4. pK again both are same. So another side will become equal to 0. When we will take the anti-log of you can say the 0. The answer will be equal to 1 and 1 is always equal to 1 by 1. So ionized form is equal to 1 and unionized form is also equal to 1. So the ratio between the ionized and the unionized form in case of in case if the pH is equal to pK, the ratio will be equal to 1. So that speaks that whenever the pH is equal to pKa, the ratio between ionized and the unionized form of that drug will be equal. So next moving to the next slide, that is about the distribution. ये वो चीज़ें हैं जो प्रीवियस हमारे यहाँ ड्रग अब्जॉर्प्शन से रिलेटेड हो सकती हैं, इंटेस्टाइन में क्या होता है, स्टमक में क्या हो रहा होता है, and finally the drug is there in the blood and it has to be distributed. Again, the ionized and unionized ratio play a very important role because it is the unionized form of that drug that crosses the membrane. The ionized form, because it carries the charge, it is water soluble, it cannot cross the membrane through passive transport. But it is the unionized form of drug that crosses the membrane through passive transport. Oh, okay, so the pKa value is 4.8 and pH is equal to 7.4. If you see, the pH is equal to 7.4, pK is equal to 4.8, means the drug is acidic in nature. So the answer will be equal to 10 raised to power minus 2.6, and the antilog of the 2.6 will be equal to, you can say, it will be equal to the 398 के equal हो जाता है divided by 1. So you can say the ionized form of that drug will be more, and the unionized form will be less because the pH has been increased. So this means that the ionized form of drug is more and the unionized form of drug is less. That speaks that the distribution of drug into the tissue will be less because the ionized form is less as compared to the ionized form. So the drug become highly ionized in the blood and drug will be trapped in the blood. It will not be moving to the tissue because the unionized form of the drug is very low. Okay, so next example, the first example is about the basic drugs, and the best example is the morphine, and the morphine has got around pKa value of 8, and if the pH is equal to 10, what will be the ratio between the ionized and unionized form if the drug has got this kind of data? So calculating, applying the equation for the weak basic drug, that is called as pH is equal to pKa log of unionized over ionized. So the answer will be equal to 10 is equal to 8, so 2, and then by taking the anti-log it will be equal to 100 divided by 1. So that speaks that the unionized form is 100 molecules and the ionized form is 1 molecule. तो जहाँ पे आयोनाइज जो है 100 मॉलिक्यूल्स, 1 मॉलिक्यूल है आयोनाइज्ड का, और अनआयोनाइज्ड का the 100 molecules are there. So that means that कि जब pH of the any drug that is pKa is 8, pH is 10. So if the pH is increased, अगर pH increased हो जाए और drug basic हो, so as you will increase the pH, the unionized form of that drug will be increased, ज़्यादा increase होगी. अगर आप pH को decrease करेंगे, from the pKa value से decrease करेंगे, the ionized form of that drug will be greater than the unionized form. तो इस केस में unionized it is greater. आप जहाँ पे देखें तो नोमिनेटर में the unionized, जहाँ पे न्यूमिनेटर में unionized form और ionized is equal to 1. So that means that if there are 101 molecules, only 1 molecule will be ionized and 100 molecule will be unionized. That is the basically the true story about the morphine. Now, if the pKa value is 8 and the pH is equal to 6, what will happen? Again, this is the we will apply the basic equation for the Henderson Hasselbalch equation जो हमारी basic drugs के लिए use होती है. pH is equal to pKa log of unionized over ionized, and we will have this answer that will be equal to, you can say, antilog of 0.01, that will be equal to sorry, the antilog of -2 will be equal to 0.01, and our answer will be equal to 1 over 100. That speaks that the ionized form is, if there are 101 molecules, only one molecule only one molecule will be the unionized form, and most of the drug will be in ionized form में हमारी होगी. So this is about the morphine, about the basic drugs. And if the pH and the pKa value is equal, again the same formula. If the pH is equal to pKa, the ratio between the ionized and unionized form of that drug will be equal. And here you can see from the equation K ratio is equal to 1 by 1. So ratio इनकी equal होती है. Okay, so moving to the next slide, that is about the drug distribution inside chloroquine. हम एक और ड्रग की जो एग्जांपल है, दैट इज द क्लोरोक्विन. क्लोरोक्विन की जो पीके वैल्यू दैट इज इक्वल टू 8 और ब्लड की पीएच दैट इज द 7.2. आई मीन के जो ब्लड मीन्स के जो ब्लड का सेल्स हैं, आरबीसीज हैं, उनकी पीएच, blood cells pH. I means the RB, red blood cells pH. Okay, so this is the red blood सेल का जो फ्लूइड है, रेड ब्लड सेल्स फ्लूइड का जो पीएच है उसकी दैट इज 7.2. So again they we will like apply the basic equation because the drug chloroquine is basic in nature, and our answer will be equal to you can say the minus minus 8 के equal होगा, and by taking the anti-log our answer will be equal to 1 divided by 6.3, which means that the one molecule will be ionized and 6.3 molecule will be in ionized form. तो ये एक molecule to 6 ratio जो है that will be between the unionized and between the unionized and ionized form of that drug उसके दरमियान exist करती है. So that means that if you take the chloroquine will be moved to the RBCs और RBCs के अंदर जो pH है that is 7.2 और हमारी ब्लड की जो pH है that is 7.4 है. तो इसलिए जो ड्रग जाती है इनसाइड द आरबीसी इट बिकम द आयोनाइज. ज़्यादातर जो ड्रग है इट इज़ अवेलेबल इन आयोनाइज्ड फॉर्म. तो आयोनाइज्ड फॉर्म में जब ड्रग जाती है इट विल बी ट्रैप्ड, क्योंकि ये आरबीसीज के अंदर ट्रैप हो जाती है. इसके आयोनाइज्ड मॉलिक्यूल होते हैं एंड ड्रग कैन नॉट कम आउट. तो ड्रग बाहर नहीं आ सकती एंड ड्रग इज़ रेडली अवेलेबल टू किल द मलेरियल पैरासाइट इनसाइड द आरबीसी. तो इसलिए वो उसको किल करती है. And this is one of the good example where you can see के कैसे क्लोरोक्विन को डिज़ाइन किया गया है because of its chemical nature and because of its physico chemical properties and because of its target जो malarial parasite है, it is present in the RBCs and drug goes into the RBCs and it become ionized, and then this ionized form of drug produces its action. तो इसकी ट्रैपिंग हो जाती है and drug is readily available to produce its action. So here in this figure you can see के different body के organs हैं, उनका जो pH level है that differs. Like in the cochlea the pH is 7.4. हमारा जो blood है around pH 7.4 है, and saliva की 6 to 7.4, gallbladder 7.8, and pancreas, spleen, kidney, bladder, uterus, muscle, so small intestine, large intestine. So the pH is variable, but the pKa value of the drug is fixed. So if the pH is variable, that means that the drug concentration the ratio of ionized and unionized form in different tissue, it will be different depending upon the pH of that organ or pH of that organ fluid उसके ऊपर depend करता है. So that's why the Henderson-Hasselbalch equation, it is very helpful to manage the toxicity, because if there is a you can say that if there is a urinary acidification accelerates the excretion of weak basic drugs and retard that of the weak acidic drug. हमारी जो यूरिन है इट इज़ ऑलरेडी एसिडिक इन नेचर. अगर आप इसको फर्दर एसिडिक बनाते हैं द weak basic drug will be very quickly eliminated from the body. If you will make it more acidic, if you will make it more basic, then acidic drug will be more readily excreted from the urine, क्योंकि आपकी ड्रग जो है आयोनाइज्ड हो जाती है. सो पी के वैल्यू अगर ड्रग की आई मीन एसिडिक की तरफ है and drug and the urine is basic in nature, then it will be eliminated. So that's why urinary cleansing has the opposite effect. It reduces the excretion of weak bases and increases that of the weak acid. ये दोनों अपोजिट हैं. एसिडिफिकेशन का अपना एक इफेक्ट है और अल्कलाइनाइजेशन का अपना इफेक्ट है जब आप इसकी पीएच को इंक्रीज या डिक्रीज करते हैं. डिक्रीज पीएच के ऊपर द you can say the pH को decrease करते हैं weak basic drugs, they are readily eliminated because of the ionized form. अगर pH को आप increase करते हैं, the weak basic drugs they are easily excreted from the body. So increasing the plasma pH by the administration of sodium carbonate causes the weakly acidic drug to be ionized and excreted in the plasma from the CNS. इस तरह CNS से भी एलिमिनेट हो जाते हैं जब आप प्लाज्मा को वो करते हैं, आयोडीन के इंक्रीज करते हैं पीएच को. Acidic drugs where they are extracted from the CNS and excreted in urine. So treating aspirin, barbiturates, very good example. They are acidic in nature, but if you will increase the pH of the plasma, drug will come into the plasma, will be converted into ionized form, and then it will be eliminated. That is the trapping. So moreover, decreasing the pH causes the neurotoxicity. अगर आप इस केस में pH को decrease कर देते हैं, so that will cause the neurotoxicity के chances होते हैं. That drug can go into the CNS, so that will cause the toxicity. So decreasing pH causes neurotoxicity such as acetazolamide causes weakly acidic drug to become concentrated in the CNS. उसमें वो कर लेता है. So this is all about the you can say that to calculate the ratio between ionized and the unionized form. Again, this knowledge is very important when you are basically concerned कि आपके कितने total molecules हैं और कितने molecules they will be available in ionized and how many molecules they will be available in ionized form. So it is the pH that determines कि drug की जो ionized और unionized form की ratio है वो किस तरह exist कर रही होगी. So with this I will conclude today's lecture. If you have any question, more than welcome. Please mention in the comment section. Thank you.